Let us take a control system has n number of state variables. Okay. So what are the state variables? We will take as x1, x2 and so on till xn. Now all of these state variables you can consider it to be n components of a single vector. And this vector we write as x of t. So this will be x1, x2 and so on till xn. You can write this as a function of time. Okay. So what will be the order of this matrix? N into 1. So this is called as the state vector. The vector that we are most familiar with is the vector in vector algebra we see a I bar plus b j bar plus c k bar. This is a vector having 3 components, right? In matrices, when we saw vectors, if you consider a row matrix or a column matrix, this is a row matrix and this is a column matrix. Let's say there are n number of columns here. So how you will write 1 into n, 1 row and n columns. So now n will be the number of components of the row matrix. Similarly, for a column matrix, if there are n number of rows and 1 column, then n will be the number of components. Similarly, here the state vector, you have n into 1 as the order of the matrix. So there will be n number of components for this vector. Okay. Now we will see what is the state model. Consider a control system which is having n number of state variables, p number of input variables and q number of output variables. Okay. Then you can write the state equations. What are the state equations? The first order, n number of first order differential equations, right? So this will be in the form of usually dx1 by dt, differentiation of the state variable. So this will be the function of the state variables as well as the input variables. Okay, so here you have taken n number of state variables and p number of inputs. Similarly, you can write for dx2. Okay, so in general, you can write for an ith state variable. For ith state variable, dxi by dt, you can write as the ith function of x1, x2 and so on till xn, u1, u2 and so on till up. So the basic idea is that the differentiation dxi by dt will depend on all of the state variables as well as the inputs. If it is not depending on any of the state variables, then that particular state variable will not appear in the function. As simple as that. Okay. Now just like the state equations, another set of equations that you have is the output equations. So that means the output y1, y2 and so on till yq. We have taken q number of outputs, right? So this will also be some function of the state variables as well as the inputs. Okay, if it is not depending of the output, if for example y1 is not depending on xn, let us say, then xn will not appear in this function. Okay, in general we write like this: g1, which is a function of all of the state variables and all of the input variables. Similarly, y2 you can write g2 of this variables. This is gq of this variables. Okay, so in general you can write for ith output yi is equal to gi x1, x2 and so on till xn, u1, u2 and so on till up. These both, this state equations, there will be how many number of state equations? N number of state equations will be present. These n number of state equations plus the output equations, how many output equations will be present? Q number of output equations. All of these together, they form the dynamic equations. Okay, so you can write dynamic equations of the system are n number of state equations and q number of output equations. These equations together, they can describe the system completely. Okay. Now, if you consider the specific case of LTI system, linear time invariant systems, then the dynamic equations, they can be written something like this. For example, if you take dx1 by dt, how did we write? f1 function of x1, x2 and so on till xn, and u1, u2 and so on till up. Okay, so this is in general, that means it will apply to any function, but specifically if you take for an LTI system, then what will happen, you can write this as dx1 by dt is equal to a11 x1 plus a12 x2 plus so on till a1n xn plus b11 u1 plus b12 u2 plus so on till b1p up. So these are all constants here. a11, b11, b1p, these are all constants here. Why? Because this is an LTI system. An LTI system can be represented in this manner. So in general, you can write for an LTI, in general for an LTI system, the state equation can be written as dxi by dt is equal to ai1 x1 plus ai2 x2 plus so on till ain xn plus bi1 u1 plus bi2 u2 plus so on till bip up. Okay. So now all of these equations for I is equal to 1 to so on till n, and also one other thing is these are all constants, right? ai1, ai2 and so on till ain. So in general we can write as aij and similarly bij. These are constants. Okay. So now these we can write as, all of this we can represent in a matrix form as dx1 by dt, dx2 by dt and so on till dxn by dt. So this will be equal to a11, a12 and so on till a1n into the state vector x1, x2 and so on till xn plus also b11, b12 and so on till b1p into the input vector u1, u2 and so on till up. Okay. So you can see here dx1 by dt is equal to a1 x1 plus a12 x2 and so on till a1n xn plus b11 u1 plus b12 u2 and so on till b1p up. So you can fill out the other elements as well. It is going to be a21 and so on till a2n. Finally an1 and so on till ann. What about here? This will be b21, b22 and so on till b2p and so on till bn1, bn2 and so on till bnp. You write down the order of each of the matrices as well. Okay, so what is the order of this matrix? It is n into 1, n number of rows and 1 column. What about this matrix? Here it is going to be n into n, and this is n into 1. Here it is going to be n number of rows into p number of columns, and here you have p number of rows into 1 number of column. So you can see here when you multiply two matrices, and what will be the order of the resulting matrix? It is going to be this n here, number of rows of this matrix into number of columns of this matrix. When the number of columns here and the number of rows here, they are matching, n here is equal to n. So the order will be n into 1. Similarly here p and p are matching, so multiplication is possible and the resulting order of the matrix is n into 1. Okay, which is equal to n into 1 matrix. So this is a correct one. This is how sometimes you can check out whether a certain matrix equation that you're writing it is correct or not. So now finally this matrix you can write as d by dt of the state vector, or you can also write this as x dot of t. Okay, and this matrix you can write as A, and this is anyways nothing but the state vector. This matrix you can write as B, and this is the input vector. Okay, so finally you can write as x dot of t is equal to ax of t plus b u of t. Okay, remember this x and this x here, these are all vectors. These are not just simply u of t, not just a simple function, but these are vectors. So it is better if you can write them in bold. So this is the state equations. You have written in terms of the vectors x bar of t, x dot of t, x of t and u of t. Okay. Similarly, you can write the output functions as well. How did you write the output functions? If you take yi, you wrote it as gi x1, x2 and so on till xn, u1, u2 and so on till up. For an LTI system, you can write in terms of constant coefficients. So y1 will be equal to, we will take c11, okay, c11 x1 plus c12 x2 plus so on till c1n xn plus d11 u1 plus d12 u2 and so on till d1p up. Similarly, y2 you can write and so on till yq. There will be q number of outputs. We have taken q number of outputs. So what is this going to be? cq1 x1 plus cq2 x2 plus so on till cqn xn plus dq1 u1 plus dq2 u2 and so on till dqp up. So how will you write this in the matrix form? y1, y2 and so on till yq will be equal to c11, c12 and so on till c1n, c21 and so on till c2n, and this is going to be cq1 and so on till cqn. Okay. What will be the state variables? x1, x2 and xn plus d11, d12 so on till d1p, finally dq1 and so on till dqp. Here you will have the inputs. You will have till up. You can write down the order of each of the matrix here. This is going to be q number of rows into 1 number of column. Here you are going to have q number of rows into n number of columns, and this is n number of rows into 1 number of column. Here you have q number of rows into p number of columns. Here p number of rows into 1 number of column. So you can see here this n and this n is equal. So multiplication is possible. The resultant is q into 1. Here p and p are equal. Resultant will be q into 1, which is equal to q into 1. So this equation is also correct. So now this you will represent as y of t, this as c, this is the state vector x of t, this will be matrix D, and this will be the input vector u of t. So you can write as y of t is equal to c times x of t plus d u of t, and you can also write in bold letters here to represent that these are not just simple individual functions, but they are vectors. Similarly, c and d, these are not simple constants, they are matrices. So this is the output equation in vector form. Okay. So these both together, they are called as the dynamic equations, and you can also draw a block diagram to represent both these equations. Okay. So how is that block diagram going to look like? First you take an integrator. Okay, so you either represent with the integration symbol, or you can write 1 by s, which is the, in Laplace domain, integration function, you are going to get 1 by s. So for this, if you give x dot of t, that is dx by dt, then this integration will give you x of t. So this is the first step. Then again, x from the state equation, x dot of t is equal to a times x of t plus b times the input vector. So first you can draw this a here. This is the a vector, and this is going to go to the summer function here. Okay, so this is plus. Now what is remaining? You will have to write the input function as well. So this will give you b into u of t will be present here, a into x of t will be present here. If you add both of them, you are going to get x dot of t. This is going to be the arrow. So first equation we have written, state equation. Okay. Next what do we have is the output equation. So the output equation, y of t is the sum of c into x of t plus d into u of t. So from x of t to this summer, you can put a function here, transfer function, which is c. Okay, so this will go till here. This will be plus, and from u of t, the other transfer function will be d. d times u of t will get added here. So c times x of t and d times u of t will give y of t. This is the state model of the control system that we have considered. Okay. One thing that you have to remember is that here these functions are not single functions, but they are vectors. Okay. Here very important point is this, it is not a normal block diagram. Okay. U of t, x dot of t, x of t and y of t, these are not single or individual functions, but they are vectors. Similarly, a, b, c and d, these are not just constants, but they are matrices. In the matrices anyways, they are constants only. The elements, each of the element is a constant element. Okay, but they are not single constant, they are matrices.